So this is going to be a section on derived units. So what is a derived unit? So here's our section titles. We have derived units, and two derived units are going to be volume and density. Alright, so what is a derived unit? So a derived unit is basically a combination of base units. So for example, we have meters cubed, we have centimeters cubed, meters per second, or grams per milliliter, right? What's a meter cubed? It's just a meter times a meter times a meter. So that's a combination, meter times a meter times a meter. Centimeter cubed, same thing, centimeter, centimeter, centimeter. Meters per second, we have a meter and a second. And grams per milliliter, that's just grams and milliliters. Okay, so what's a volume? So a volume is the space occupied by an object. So for example, we have these shapes, right? This is a cube. So how do we find the volume? It's just length times width times height. So length times width times height, right? So let's just say that this was, let's say, I don't know, 1 meter. And the height was 1 meter and the width was 1 meter, right? So then how do we calculate the volume? So we take 1 meter times 1 meter times 1 meter. What's 1 times 1 times 1? Just 1. What's a meter times a meter times a meter? So meter cubed, right? So this box would be 1 meter cubed. So there's different ways that we can express volumes. For example, this one would be meters cubed. For something like this, we could measure it in, I don't know, centimeters cubed or milliliters. And how much is 1 centimeter cubed in milliliters? It's just 1, right? So if we had 40 milliliters, how much is that in centimeters cubed? It would just be 40. So it's 1 to 1. Centimeter cubed, same thing as saying milliliters. Alright, so for our other derived unit, we have density. So what is density? Density is how much matter is in a given space. So how do we write that equation? So we just write density equals the mass divided by the volume. So how much stuff is inside a given space? So for example, let's do a problem. So let's say that we have this cube. So is this block pure aluminum? We can find that out. So let's just say that we looked it up online. So density of aluminum. The density of aluminum would be 2.7 grams per centimeter cubed. Alright, so let's say that we took measurements of this cube and we found that the mass is 13.5 grams and the volume would be 5.0 centimeters cubed. So we took the length times width times height, found that it's 5 centimeters cubed. We took a scale on this cube and we found that it's 13.5 grams. Alright, so let's take the density of this cube. So density, what's density again? Density is mass divided by volume. So what's the mass here? Grams. And what's the volume? 5 meters cubed. So let's just take that, plug it into our formula. Alright, so we have 13.5 grams divided by 5.0 centimeters cubed. Alright, so how do we divide this? plug it into a calculator maybe. Maybe you can do it by hand. But either way, density equals 2.7, right? So we get the 2.7 from this 13.5 divided by 5.0. And for our units, we still have to divide our units. So grams divided by centimeters cubed. So we get 2.7 grams per centimeters cubed. All right, so is this density, is that the same as the actual density of aluminum? Yes. So this would be pure aluminum if we measured it. All right.